Alright, hello everyone, welcome to the channel. Today we're going to be covering a very important topic in math, in calculus, called integration. So we're going to focus in this video on conceptually understanding what an integral is, what it means to take the integral of something, less on the mathematical formulas and routines that are associated with integration. We might cover those in another video, along with those for differentiation, but for this video we're just going to try and understand what this means. So integration is an operation in calculus. It's notated using this symbol. You'll notice it looks like a curvy S, right? This S comes from the word sum, because as you'll see later, the way people used to take integrals is they would sum up a bunch of things. Okay, so what does this measure? Integration measures how much of something has been accumulated over time. That's all it means. So it could mean how many people are in a city, it could mean how many animals are in a zoo, how much of this has accumulated over some time, right? This is actually the opposite, which we'll show in another video how they're opposites, but this is actually the opposite of another thing we've covered called a derivative in this channel. If you haven't watched that video yet, I strongly suggest you go watch that video on introducing derivatives, because they're very important to understand integrals as well. If you remember, the derivative is how fast something's changing, the rate of change. How fast is, I don't know, the population changing? How fast is the number of bacteria increasing in a sample, right? And let's focus on this example. You might recall from the video, we use an example of if you're traveling in a car. Sounds like this is a car. I'm sorry, I'm not the best artist. When traveling in a car, right? Say you're on a number line, I don't know. And let's say your position is 2, right? The velocity is the derivative of your position. How fast is your position changing with respect to time, right? That's literally just what velocity is. Likewise, integral, the integral of velocity, v, with respect to time, is your position. This is basically just saying velocity. When the velocity accumulates over time, how much have you traveled? How much is your position? So yeah, that's one example of the integral. I want to do another example with population. Let's say we have a city. Right. Okay, so this is a city here. Let's say at t equals 0, the population is 0. It's an empty city. Over time, people begin entering this city. Let's call this function I of t. People entering the city per day, right? So the units of this are people per day. They begin entering the city. There's also another function, e of t, again measured in people per day, but this is people leaving the city. So given this, I want you guys to take a moment and think, how can we measure the number of people in the city at any given time? I'll give you a moment to pause the video and think about this. Alright, so the way to do this is, we know that I of t and e of t are people per day. And as you accumulate people per day, you're just going to get people, right? So what that means, the integral of I of t dt, remember dt because we're doing this with respect to time, that's going to be number of people. But we also have e of t, the number of people exiting. That's a really bad hashtag. So how do we find the number of people? It's very simple. The integral I of t minus e of t, rate in minus rate out. These kinds of problems are very important in calculus. These are rate in, rate out problems. So I definitely want people to be familiar with that. So let's think about this too. If I of t is greater than e of t, then, there's going to be more people coming in than out, right? So the population is going to be increasing. But if e of t is greater than I of t, more people are leaving, so the population is decreasing. Go to another page here. Now that we've learned what the integral is conceptually, let's learn how to actually apply this in math problems. We learned that if you want to find the derivative of something, let's say we have some function here, f of x, on some graph, x, y. To find the derivative of it at a point, say over here, you have to take the slope at this point, the tangent line, which looks something like this. So that's a derivative. How do we find the integral? The integral of a function f of x. Now let's say we're on some interval a to b. Say this is a, this is b. The integral is the area under the curve from a to b. And the way we write this in calculus notation is integral a to b f of x dx. This dx is just telling us we're going towards the x-axis, right? We're integrating towards the x-axis. So everything has to do with respect to x. So let's look at a few other applications of integrals in the real world. In physics, integrals are extremely important. There's a concept in physics called work. And work is basically what you do when you push an object a certain distance. And this is calculated as the integral of your force with respect to position, is dx's position in this case. In economics, the total cost of something is equal to the integral of the marginal cost. That means when the marginal cost accumulates, you get the total cost, right? So yeah, guys, that's basically integration. It's all about seeing how much of something has accumulated, how much is built up over a certain period of time. And these are very useful, they're very important in calculus. In the real world, if you go into physics or engineering, you're definitely gonna need to know these. So this is a quick intro. In another video, we'll show you guys some techniques for actually mathematically taking the derivatives and integrals of certain functions. But yeah, for now, I just want you guys to get a good grasp of what integration is. As always, thank you guys very, very much for watching. We hope you liked the video. Please subscribe and share this to your friends who might need some help. Have a good day, everyone.